Hello. So in this video, I am going to cover adding and subtracting rational expressions with like denominators. Okay, so let's go ahead and take notes. Adding, subtracting, rational expressions. And this one is dealing with denominators that are not the same. So if you remember when you learned how to add and subtract fractions, you have to have the same denominator. So here, it's the same thing, but we will not get into finding the LCD to add until tomorrow. Okay, so let's take a look. Oops, you know what? This is supposed to be like denominator, so let's change that. Like denominators. Okay, so for example, if you have something like this, suppose you have x squared minus 2x plus 3 over x squared plus 7x plus 12. And we are subtracting, okay? And we're subtracting this rational expression over here over x squared plus 7x plus 12. Okay, so here, if you notice, the denominators are actually the same, okay? When the denominators are the same, then you are able to add or subtract the two fractions. Okay, so the denominators are going to remain the same. And what happens? So our denominator in our answer will still be x squared plus 7x plus 12. There's no factoring here when the denominators are like. When they're unlike, then you have to factor and go through the process of finding the LCD. But when they are like denominators, you don't have to do any factoring. All you're doing is combining like terms. So now you're going to go ahead and take this polynomial over here, and you're going to subtract this polynomial over here. Okay, so you just combine the like terms, but just be careful when it's subtraction because you're doing x squared minus x squared. X squared minus x squared is 0, okay? But I don't have to write 0. Okay, and then here you're doing negative 2x minus negative 4x. Negative 2x minus negative 4x. Minus negative 4x is positive. So here's something you can do. When this is subtraction, if it makes it easier to change it, let's see, I'll use blue. Okay. If it makes it easier to just distribute the negative to this polynomial, then you can do that. Change that to plus, and then change all of these signs. You could do that, okay? And so that you can go, okay, x squared and negative x squared, that cancels out. Negative 2x and positive 4x, that's 2x. And 3 and 5 is 8. Okay? All right. So at this point, great. All you do is combine like terms up here, keep the denominator. It's going to be the same when these guys are like denominators. Okay. But just like in the past when you're adding fractions, like if you have, let's see, suppose that you have, let me think of one. Suppose that you have like 2 over 8 plus 4 4 over 8, right? Suppose you have this. Well, you would just add and you would get 6 over 8, right? Okay, so, but do you remember when you have this here, you have to simplify your answer, right? We learned how to simplify rational expressions as well. Okay, so when you combine your like terms, don't stop there. Make sure with your final answer, if you can factor, go ahead and factor just to see if you can cancel any common factors. So in the numerator, they have 2 in common. So I'll factor out a 2 and I'll have x plus 4 left. And over here, I have a trinomial, so x times x to make x squared. I need positive, positive, and it looks like to make 12, it's going to be 3 times 4. That way I get 7 for the middle. And I notice here that the x plus 4's do cancel. So my final answer here is 2 over x plus 3. So don't leave it like this. Okay, combine your like terms and then see if you can simplify it. Okay, so simplify, which means that you have to check to see if they factor and if you have any common factors. Okay, all right, let me do another one. Let's see. So that's subtraction. Let me do an addition problem here. Okay, so let's go ahead and then that's it. I'm just going to do these 2 examples. Okay, so x squared plus 3x minus 2 all over x squared plus 3x minus 10 plus 4x plus 12 all over x squared plus 3x minus 10. Okay, so again, the denominators are like, so all I have to do is combine like terms. Okay, so I'm going to combine all of these, and I'm going to add them, so I don't have to change the signs of this second polynomial. Okay, so I'm going to go ahead and combine these here, so I get x squared. There's only x squared. 3x plus 4x is 7x. And then negative 2 plus 12 is negative 10. No, positive 10. Okay. And then down below, we have the same denominator because we have like denominators. The denominators are exactly the same. Okay. But again, don't stop here. Simplify. So we have to factor first. Okay. So I'm going to factor the numerator, and then I will factor the denominator. So in the numerator, x times x to make x squared. I want to make positive 10, so it'll be positive and positive, because I also want positive 7 for the middle term right here. Okay, so I can use 1 and 10 or 2 and 5, and it looks like it's going to be 2 and 5. That way I get the 7x. Down below, it's going to be x times x to make x squared. And then here, I don't want positive 10 like up here. Instead, down here, I want negative 10. So that means the signs here have to be different. So one will be positive and one will be negative. That way I get negative 10. Okay, so here I can use 1 and 10, or I can use 2 and 5. And remember, one of them is going to be negative. Okay, so I want to get positive 3 for the middle. So it looks like it's going to be this combination over here, 2 and 5. And it looks like in order for me to get positive 3, the 5 has to be positive and the 2 has to be negative. Okay. And then here, I see x plus 5's cancel out. And we get x plus 2 over x minus 2. and that would be the final answer. Okay? So again, all you have to do when these are like terms is combine, like denominators, all you have to do is combine the polynomials in the numerator. Okay? Combine like terms in the numerators and then factor and simplify. Okay? All right. If you have any questions, make sure you ask me.